Welcome to the instructional video for the Quarterly Mortality Monitoring Report Excel Workbook. My name is Patrick Weiss. I'm an actuary in the SOA's research department, and I'm going to give you a brief tour of the workbook. Going forward, the SOA will update this workbook every 3 months with fresh data. The updated workbook will be released on the SOA's website along with an updated report. The report provides a high-level overview of U.S. general population mortality trends. The workbook is available for anybody who wants to take a deeper dive into the data. As a data source, the workbook uses death counts for the U.S. resident population from the CDC, the Centers for Disease Control and Prevention. This version of the workbook contains data from January 2000 through December 2024. Due to reporting lags, the data from August to December 2024 is incomplete. We estimate that the data for August 2024 is about 99.9% complete. The level of completeness gradually declines to about 99% for December of 2024. That is, the more recent the month of death, the less complete the data. So please be mindful of this fact when generating results. The CDC death data in this workbook is disaggregated by month of death, by sex, by individual age, and by 14 major causes of death. The workbook provides several tools to facilitate the analysis of mortality trends, including interactive parameterized graphs that make it easy to visualize the data. The workbook has a Contents tab where each of its worksheets are described. The first 6 worksheets are outputs, both output tables and output graphs. All of the tables and graphs are dynamic, meaning that there are parameters that allow you to specify the specific data that you want to look at and to visualize. Worksheets 7, 8, and 9 contain the data. Worksheet 10 provides some information about the data sources. Worksheet 11 discusses some of the methodology that is used in this workbook. And worksheet 12 is a user guide that describes how to generate outputs on these first 6 worksheets. Lastly, the Contents tab describes the 14 major categories of deaths into which the data is disaggregated. And you'll see the ICD codes that were used to perform the disaggregation. Let's go ahead and look at the first worksheet. This worksheet produces time series of death rates for user-specified ages or age groups. You'll see there's a help button, and all of the output worksheets contain help buttons. Let's go ahead and click the help button, and it takes us to a user guide with a series of illustrative examples that are helpful for understanding how the various parameters in the workbook, what's their meaning, and how do they control the outputs that are produced. I'd suggest starting here when you first open the workbook and take a look at each of these examples. I think they'll answer most of your questions regarding how to operate the workbook. Let's go back to worksheet number 1 and let's generate some output. So let's look at output from January 2018 through December of 2024. And let's produce output on a monthly basis, which is controlled by this parameter C10. I can change this parameter if I want. If I changed it to 3, the outputs would be produced on a quarterly basis. If I changed it to 6, it would be a semi-annual basis. And 12, it would be output 1 output point per year. For this example, let's produce monthly output. Now we move down to uh, the parameters that begin on row 21. We call these cases, and you can generate up to 100 cases in a single run. For sake of simplicity, let's just generate let's generate 2 cases. Each of these cases, we're going to focus on an age group rather than an individual age, but there's nothing stopping you from focusing on an individual age. So if I were to type in these parameters, we'd be focusing solely on age 65. If I were to type in these parameters, we'd be looking at the 5-year age bucket from 65 to 69. You're free to specify whatever you want here. I'm going to look at age 65 to 69. I'm going to use age standardization, which is explained in the user guide and also in the methodology section. So I'm not going to dig into that now, but I think the user guide will answer your questions. I'm going to look at male and females combined, but if I wished, I could look at males or females separately. But for this example, let's combine the sexes. I'm going to look at all causes of death summed together. These are mutually exclusive causes of death, and when we sum them together, we get the total. But if you want, you can look at any of these separate categories. For this example, let's look at total deaths. There are 4 different metrics that you can generate: the actual mortality rate, an expected mortality rate, which is defined and explained in the user guide. And so I won't get into that here, but I think if you go to the user guide, hopefully your questions will be fully answered. You can also look at actual over expected mortality rates, or you can look at mortality for a specific cause as a percentage of all causes. For these examples, let's look at the actual mortality rate. We're going to look at two different metrics, actual mortality rate metrics. This first metric in case 1, every output that we generate, every output point, will be a 12-month trailing average. It will be based on the trailing 12 months of data. So if we produce output for January of 2018, it will be based on data from February of 2017 through January of 2018. You can set this parameter to whatever you please. So we could look at we could pool 3 months together, 6 months together, 12 months together. I'm going to set this first parameter to 12. The second parameter I'll set to 1. And so in this case, every output is simply a single month's worth of data. So for January 2018, we'd be looking at deaths in that month, and we'd be comparing those deaths to exposure in that month. These parameters, L in columns L, M, and N, are used for defining expected death rates. This is explained in the appendix. So in this example, since we're not using these parameters, I won't get into the explanation. We can either indicate that we would like to place the metric on the graph, or we would not like to. Let's put both of these metrics on a graph. We indicate that with the letter yes, with the letter Y. And then we have to specify a label that will appear on the graph. Let's type 12-month average, and this is just monthly. Let's go ahead and run this. We get a warning message that discusses the data completeness issue that I mentioned a few minutes ago. Keep in mind that uh, for this data set, the CDC data from August 2024 onwards is not complete. So we need to be mindful of that when we look at these results. We run, we have time series of results in tabular form, and we can also look at these results on a graph. Let's go ahead and do that. Here's the graph. If we wish, we can change the boundaries of the y-axis. I'm going to go ahead and do that. I'm going to specify 3% as the minimum that I want for the y-axis. I press this button. The graph adjusts. And we see one time series, the time series that's based on trailing 12 months of data. That is quite a bit smoother than the monthly time series. So the monthly series has a lot more volatility as we would expect. We're looking at the death rate for the 65 to 99 age group, and we see that it's relatively flat for a couple years, and then when we reach the pandemic, we have a very significant increase, and then uh, a slow decline. Let's do one more run here. Let's look at another metric. Let's look at actual divided by expected. For expected, we're going to use 2019 data to define the expected death rate. So 2019 data will be used to define our expectations. Let's change the label on the graph to A over E, and let's run again. And let's look at the graph. Let's reset the range. Let's make the lower boundary 90%. And we see in the period leading up to the pandemic, by design, by definition, the result here is 100% because we're comparing 2019 data to itself. And so A over E is 100%. Then we hit the pandemic period. We see a very steep increase. And by the way, this is the 12-month trailing average. The peak is over 120%, so that means that mortality jumped by 20% relative to the base year 2019. And since then, it's gradually declined, and we're about where we started now in 2019. Keep in mind that the data is not complete, so you have to be careful these last few months interpreting the results. I'm going to stop the presentation there. My hope is that the user guide is sufficient to answer most or all of your questions. If you have any additional questions, please feel free to contact me here at the SOA. Thanks for watching. Take care.